you are coming in, just begin to say I. As you are coming in, just begin to say I. Okay, you're welcome once again. Okay, so look at the question we have here. The curve C has an equation y equal to 4x squared plus 8 minus x over x, and then we are told that x is not equal to 0. The point P on C has x coordinates 1. A show that the value of the y dx at point P is what? Is 3. Okay. B, find an equation of the tangents to C at P. Okay. And then we have this one. The tangents meets the x-axis at the point k, 0. Find the values of k and equations of tangent and normal. Please begin to invite your friends. They are coming here for the first time. Make sure you subscribe to the channel, okay, and begin to share the links across your social media platform. Begin to share the links across your social media platform. For the introduction, okay, the part 1, we gave equations of tangents and equations of normal. Okay, and I said that equations of tangents is this. That's the equations of tangents, where your m is the y dx, is the slope or the gradient. Slope, or you call it a gradient. Slope or gradient. And then your x1, y1 is a coordinate point. X1, y1 is a coordinate point. Okay. So this is the coordinate points. This is the coordinate points. Okay. This equation is a point gradient equation. We can as well use this equation. We can use this equation also. The choice is yours to get the equations of tangents. Okay, where m is a slope or the gradient and c is a y intercept. Okay, and then the next one we said is the equations of normal. Equations of normal, and that's if you are looking for equations of normal, we need to get the gradient of normal. We need to get the gradient of normal, okay, which is -1 over m. Okay, so equations of normal will be this one. Okay, so that's the introduction. Without much ado, let's go straight to the questions and find solution to the questions. Equal to 4x squared plus 5 minus x over this. So let's do the algebra of this one. So y will be equal to this one plus 5 over x. This will be this over this minus this over this, and that's -1. Okay. Then the derivative y dx of this function will be differentiate this one. That will be 8x, and then differentiate this one. That will be -5 over what? X to power 2. If you differentiate 1, that will give you 0. So that's what we have for the derivative. That's what we have for the derivative. Then we can get the derivative, the y dx at x equal to 1. Put it in this equation. That will be 8 times 1 minus 5 over 1 to the power 2, and that gives us what? 3. So we have shown that the values of the y dx at point P is 3. So that one is done. That one is done. As you're coming in, just begin to say I, okay, and begin to share the links of these particular video across your different platform. Don't stop there. Begin to call your friends, okay. Call your friends right now to join us. When x is equal to 1, let's get the y is equal to, substitute that one into the given equation, into your y function. That will be 4 times 1 square plus 5 minus 1 over 1, okay, and that will give us 4 plus 4, and that's what? That's 8. That's 8. So the coordinate is 1, 8. When x is 1, y is 8. When x is 1, y is 8. Okay, so we can quickly get the equation of tangents using your formula. Y minus y1 equal to the gradient times x minus x1. Okay, then that will give us what? That will give us, this is my x1, this is my y1. Okay, so we have y minus 8 equal to, my slope is what? Is 3, okay, times x minus 1. Then you can open the brackets, and that will be equal to what? 3x minus 3. Okay, then we can move this minus 8 to the other side, and that will be equal to y equal to what? 3x minus 3 plus 8, and that's what? 3x plus 5 on that question. Then we have the C part, the tangent. This tangent meets the x-axis at the point k, 0. Okay, find the value of k. Find the values of k. Meet the x-axis. Okay, if the tangent meet the x-axis, it implies that y is what? Y is 0, is base. Okay, and when the tangent meet the x-axis, y will be 0. So you just write the equations of tangents, which is this 3x plus 5. That's the equation of tangents, and the tangents meet the x-axis, which implies y is 0. Okay, and that will give us x plus 5. So make x the subject, then we have minus 5 over 3. Okay, so in that case now, if you look at the coordinates k, 0, it implies that this is x, this is what? This is y. Y is 0 from the coordinates, coordinates. X is what? X is k. So in that case now, therefore, k is equal to what? Minus 5 over 3. So that starts on this case. C has equation y equal to x cubed minus 2x squared minus x plus 9. And then x is greater than 0. The point P has coordinates 2, 7. Show that P lies on C. Okay. B, find equations to C at P, giving your answer in the form y equal to mx plus c, where m and c are constants. Okay, let's see solution to that. P has the coordinate 2, 7. Okay, so what we are going to do is for you to know if it lies on C, we are going to, this is s equal to 2 for that coordinate, and substitute that into the given function. S equal to 2, and that will be 2 to the power 3 minus 2 times 2 squared minus 2 plus 9. Okay, and that will be equal to 8 minus, this is 2 squared, that's 4 times 2, that's 8, and then we have minus 2 plus 9. This is on C. Okay, your y value must be 7. Okay, so once you can get 7, then you can say definitely the P lies on C. Find the equation of the tangent to C at P, giving your answer in the form y equal to mx plus c, where your m and c are constants. Okay, so let's look at that. We need to get the gradient y dx of the function. So differentiate this one respect to x. That'll be 3x squared. Okay. Differentiate 2x squared. That'll be minus 4x. Minus 4x, and then minus 1. So that is the gradient. So let's get the gradient at the given point. The gradient at x equal to 2. Okay, so this will be equal to what? 3 times 2 squared minus 4 times 2, and that will be equal to what? That will be equal to, this is 4, that's 12 minus 8. So the gradient is 4. The gradient is 4. The best thing to do is to subscribe right now. Why? So that you can get notified anytime I come online. You can get notified anytime I upload new video. Okay, begin to subscribe right now. Share the links, call your friends to do likewise also. If you have subscribed, tell your friends to do the same thing also. Thank you for doing that. Okay, let's continue. We've gotten the slope, the gradients. Okay, and I want to say this is not movie. Take your journal, take your writing material, and begin to follow along with me. The gradients, which we have this, when you differentiate this one, we have this. Okay, I skip the minus 1 here, minus 1. So that will be 12. That will be 12 minus 8 minus 1, and that's what? And that's a 3. That's the gradient. Okay, that's the gradient. That's why I say you follow along with me. Okay, so let's quickly get the equations of tangents. Using this equation to get the equations of tangents. Okay, the y1, that's a 7. The x1, that's 2. Okay, and that will be equal to what? Y minus 7 equal to, my m is 3, x minus, my x1 is 2. Then you can do the expansion. And this will be equal to what? 3x minus 6. Move this minus 7 to the other side, and that will be y equal to what? 3x minus 6 plus 7, and that's a 3x plus 1. So that's the tangents. That's the tangent, and we are told to express it in form of mx plus c, which we have done. My m is 3, my c is 1. Okay, given that the tangent to c at q is perpendicular to the tangent to c at p. Okay, show that s coordinates of q is what? Is this. So what we are going to do in this case is to, since we are told that the tangent to c at q is perpendicular to the tangent to c at p. So if it's perpendicular, then the tangent at p is we got 3. Okay, so then the tangent will be equal to, m will be equal to minus 1 over the gradient. The gradient will be equal to minus 1 over m, and that's minus 1 over 3. That's minus 1 over 3 for the gradients, since it's perpendicular to each other. The one at P is perpendicular. The one at C, okay, at point Q is perpendicular to to the one at P. Okay, and if they are perpendicular, that means the two slope M1, M2 is equal to what? -1. Okay, so that will give you this -1/m. So that's that. Then we are told that the tangent. So what we are going to do now is to of this equation, which is a 3 x squared minus 4x minus 1 equal to what? To the slope of the normal, which is a 1 minus 1/3, which is -1/3. We put that together. So that is what we mean by that. You put the equations of the normal, okay, to the tangents at P, and that will give us this. Then you can do the expansion, multiply both sides by 3 times 3 times 3 times 3 times 3, and that will be 9 x squared minus 12x minus 3 equals to -1. Okay, and that will be 9 x squared minus 12x minus 2 equals to 0. So that's what we have in that case. And if you check this one, you can factorize this equation, and you can use the quadratic formula. Your A is 9, your B is -12, and your C is -2. Your A is 9, your B is -12, your C is -2. Okay, and that will be equal to what? X equal to minus B plus or minus B squared minus 4AC over 2A. Make your substitution. My B is what? -12. That becomes what? 12 plus or minus. B squared is 144 minus 4 times A. My A is 9 times my C is -2. All over what? All over 2 times A. That's 9. Okay. So this one will be minus times minus. That's a plus. Minus times minus. That's a plus. Okay. So we are having 144 plus. These are 4 times 9 is 36 times 2. That's 72. So this will give us 216. This will give us 216. So we are having x equal to 12 plus or minus 216 square root over what? Over 18. Now, what we are going to do is to find the product of the factors of 2 and 6. 2 goes there, that's 108. 2 goes there, that's 54. 2 goes there, that's 27. 3 goes, that's 9. 3 goes again, that's 3. 3 goes there, that's 1. So we can group this one into 2. This is 3 times 3, that's 9. 9. This one times 4, that was 36. 36 times 6. Okay, so we're having x equal to 12 plus or minus square root of 36 times 6 over 6 times 3. What we are doing is to make this one, make it a product of two numbers, such that one of those numbers has a perfect square root. Okay, and that's what we have done in that case, and that will be equal to 12 plus or minus root 36 is 6. Root 6 over what? Over here, that's 6 times 3. So then we can have 6 is common, take it out. So we have this root 6 over what? Over 6 times 3. So this one cancel, and then we have the required s coordinates. We are told to get. We have the required s coordinates. The curve C has equation, and this is the equation: 1 over 3 s cubed minus 4x squared plus 8x plus 3. The point P has a coordinate 3, 0. Okay. A, show that P lies on C. Show that P lies on C. Let's quickly do that. then we'll now go to B part. Okay. If P lies on C, what we are going to do is to go to the coordinates. Okay, and text for when x is 3, if it lies on C, okay, then your y must be 0. Okay, and that's what we want to show now. Okay, when x is 3, go to your function y and make substitution, and that'll be 1 over 3 times 3 cubed minus 4 times 3 square, okay, plus 8 times 3 plus 3. So if you do this, it should be 0. Let's confirm that. This will be 1 over 3 times 27. This is 9 times 4. That's 36 plus 27 plus 3. So this one will be 9. This one will be 9 minus 36. These two, that will be plus what? Plus 30. Okay, plus 30. Plus 30. That's 9, 36. This one is 24. 8 times 3 is 24. It's 24. Okay, so that will be 36. 24 plus 3, that's 27. So, and that will be equal to 9 minus 36. Okay, 9 minus 36, that will be minus 27. Minus 27 plus what? Plus 27. And that's what? That's 0. Okay, so once you make that substitutions for x and you're able to get 0, that confirms the point P lies on what? On C. Point P lies on C. Okay, let's see the B part. Find the equation. Find the equation of the tangents. Find the equation of the tangents. Okay, at P. At P. Okay, at P, giving your answer in the form of y equal to mx plus c, where your m and c are constants. So let's see that. Begin to share the links of this video across your different platforms. That is one of the ways to support this channel. If you're just coming for the first time, subscribe right now. Please subscribe right now. Okay? Call your friends to do likewise. Begin to share the links across your different platforms. It's highly appreciated. Okay? So, the B parts, we need to get the gradient, which is the m. The x is the gradient. Okay? Differentiate this function. If you differentiate this one, the 3 will come to the front, and that will be 1 over 3 times 3 x power 3 minus 1, making 2, minus this power will come to the front, 4 times 2, that's 8x. That's 8x. Okay, and then differentiate 8x, that's a plus 8. If we differentiate a constant, that will be what? That will be 0. So that one is gone. So, okay, so this one and this one cancel. Then we have what? We have s squared minus 8x plus 8. That is the gradient. We need to get the gradient. We need to get the gradient, which is the slope. Okay, so then we need to get the gradient at this coordinate. S equals to what? S equals to 3. Get the gradient at that point. Okay, because in this equation there is no y in this equation. We only have is the functions of x. Okay, just substitute your s equal to 3 to this equation, and that will be equal to what? 3 squared, that's 9, minus 8 times 3 plus 8, and that's 9 minus 24 plus 8. Okay, so if you do that, we're going to have 9 plus 8, that's 17 minus 24, and that's equal to minus 7. The gradient is minus 7. You can confirm that. You can confirm that. So that's why I said you should take your writing material along with me, okay, so that we can what? We can exchange our pages together, okay, we can exchange our notes together, okay. Take your writing material. This is not a movie, okay. Take your writing material and begin to follow along with me, okay. For my returning viewers, I want to say thank you, kudos to you, okay, for always coming on board, okay. Begin to make your comment now. Make the comment constructive. Begin to type your comments, okay. Begin to share the links across your different platform. Call your friends that are yet to subscribe to join this platform, okay. I want to say you are in the right place, okay. For those that are coming new, subscribe right now. Subscribe right now. This is not a joke. This is a serious work. This is a serious work. This is a serious business. Okay, let me call it business. This is a serious business. And talking is not easy. Encourage me by subscribing to this channel. And don't do it alone. Let your friends, your classmates do likewise also. Thank you for doing that. So we got the slope as minus 7. Let me check the comment section. Okay, thank you for subscribing. Thank you for subscribing. Okay, also invite your friends also to do likewise. Thank you for subscribing. Give the videos a thumbs up. Those that have subscribed, begin to give this video a thumbs up. Begin to give it a thumbs up. If you are subscribed, give this video a thumbs up. Give it a like. Okay. The more you do that, the more the YouTube algorithm begin to share this video across the larger audience. Give this video a thumbs up. If you are subscribed, do that now. Please give this video a thumbs up. Okay. It go beyond subscribing. There are 3 things: subscribe, like, share. Okay. If you have subscribed, it go beyond subscribing. There are 3 things to do. You subscribe, you give it a like, and you share. There is love in sharing. Begin to share now across your different platforms. There is love in sharing. Okay, give it a thumbs up. Okay, don't just subscribe alone, but also what? Also give it a like and begin to share across your different platforms. Okay, begin to do that now. Okay, this is the right time. Give the videos a thumbs up. Give it likes. Okay, thank you for doing that. Thank you for doing that. Okay, thank you for doing that. Give it a thumbs up. Give it a thumbs up. Okay, thank you. I can see the response. I can see the response for the thumbs ups. Let's do that. Let's do that. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Let me emphasize more on this like. There are 3 things to do. Okay, 3 things, just 3 things. You subscribe, you give it a likes, and you share. If you like something, my principle is that if I like something, I try to share. Okay, but once I like something, I begin to share it. Begin to share it now. Okay, begin to share it now. It's very important. Okay, thank you for that. And I can see the response. I can see more likes on this video. Let's do that more. Share massively. Okay, if you subscribe, call someone also to do the same thing also. Okay, if you have shown like, tell someone also to do likewise also. That is my philosophy. If I like something, I share it. For the equations of tangents, For the equations of tangents, equations of tangents, okay, that will be equal to, this is the formula for equations of tangents. This is the formula for equations of tangents, okay, and that will be equal to, we have the coordinate points, my y1, this is my y1, this is 3,0, so y1 is what? 0, so that will be y minus 0 equal to, the slope is the m, that's minus 7, the x1 is 3, then you can do your expansion, so that y will be equal to what? Minus 7x minus 20 plus 21. So that is the gradient. That is the equation of the tangents. That is the equation of the tangents. Okay, in this form. Okay, in this form, in the slope intercept form. Okay, mx plus c. And you can see my m is 7, my c is 21. That's the y intersect. Okay, so that one is done. Once you go to the last one, another point q also lies on c. Another point q also lies on c. The tangent to c at q is parallel to the tangent to c at p. First thing to note, okay, when two lines are parallel, it implies their slope or their gradients are equivalent, are the same. Okay, if your slope at p is m1 or at q is m1, okay, that same slope or that same gradient will also be equal to the gradient at what? At p. For two parallel lines, their slope or the gradient, okay, is the same, is equivalent, okay, is constant. Okay, m1 is equal to what? M2. So that's what we are going to base the work upon. The gradient is the same. Okay, the gradient is minus 7. Those 2 points, they are parallel. Okay, and that will be equal to what? The derivative of this one, okay, is what? Is 3x. That will be x squared. That will be x squared minus 8x plus 8. So that's what we have. That's what we have. Okay, that's what we have. So, and that will give us x squared minus 8x plus 15 equal to 0. Okay, and we're going to factorize that. We're going to factorize that. The factors of 15, they can give us minus 8, either by adding or subtracting. The factors of 15, okay, that can generate minus 8. So that will be 15, that will be 3 and 5, and that will be equal to what? Minus 3 minus 5. So x is equal to what? 3 or 5. X is equal to 3 or 5. X is equal to 3 or 5. Okay, x is equal to 3 or 5. So what you now do now is to substitute this equation to the given function of y. Substitute that. So y will be equal to y is equal to, when x is equal to 3, we're going to have 1 over 3 times 3 cube minus I don't know the function, let me check that. Minus that will be minus minus 3, then 4 times 3 square, okay, plus 8 times 3 plus 3, or When x is 5, when x is 5, do the same thing also. Y equal to what? Y equal to 1 over 3 times 5 cube minus 4 times 5 square minus 8 times 5 and then plus 3. Okay, so we are going to get 1 over 3 or minus 46 over 3. The curve C has equation. The curve C has equation y equal to x squared times x minus 6 plus 4 over x, and x is positive, x is greater than 0. The point P and Q lies on C and have x coordinates 1 and 2 respectively. Okay, show that the length of PQ is root 170. Okay, so let's look at that question. What we are going to do for point P, P, when x is 1, go to your equation and substitute there. So that will be equal to what? That will be equal to 1, okay, times 1 minus 5, that's minus 5, and then plus 4 over x, that's 4. So, and that will give us minus 1. So point P is having 1 comma what? 1 comma minus 1. Okay? Okay, it's there because we have the point P and Q lying on C, and the x coordinates 1 and minus 2. So that means for P, x is 1, for Q, x is 2. Okay? Sorry. Pardon. So let's get the point Q. When x is 2, when x is 2, do the same thing also. Y will be equal to what? 2 squared. This is 1 squared. 2 squared into brackets. 2 minus 6, that's a minus 4, plus 4 over 2. And that will be equal to 4 times minus 4, and then plus 2. And that will be equal to minus 14. So point Q, we're having 2 comma minus 14. Okay? Then we are looking for the length PQ. The length PQ. Length PQ means what find the difference between P and Q. And the meaning of this is Q, point Q minus what? Point P. That is the meaning of the length or the distance between what? PQ. We start on the end, okay? And that will be equal to, for Q, we have 2 comma minus 14. My x1 is 2. My y1 is the minus 14. For P, we have 1 comma minus 1. My x are 2, and my y are 2. So we can use the formula. This is the formula to use for length PQ. For length PQ, that will be equal to square root. That will be square root. The choice is yours. That will be x1 minus y1 square plus x1 minus x2 square plus y1 minus y2 square. So that's the distance between PQ. So my x1 is what? That's 2. My x2 is what? That's 1. So minus 1, square that, and then plus my y1. My y1 My y1 is my y1. So x1, that's a 2. Y1, that's 1. Okay. Then y1, that's a minus 14. Y2, that's minus 1. Minus 1. Okay. So we're going to have 1 plus this 2, that'll be minus 13 squared. Because this is what? This is minus, that's plus. So minus 14 plus 1, that's that's a minus 13. So, and that will give you 1 plus 169. And that's what? That's a root 170. That's a root 170. So that one is done parallel to each other. Okay, let's show that. Okay. Okay, let's get the gradients. The gradients, which is m for the equation. First of all, do the expansion for your y. This one times this one, that's an s cubed. That's s cubed minus 6x squared minus 6x squared plus 4x to minus 1. So that's my y function. Now differentiate that. Your dy, the x will be equal to 3x cubed minus 12x minus 4 over what? X squared. We differentiate that. Okay, so that's the gradients. Then we want to find at point P, x is what? X is 1. Okay, at point P, x is 1. Put it in this equation. That will give you 3 minus 12. Okay, minus 4. And that will be equal to what? This one minus this one. That's minus 9 minus 4. That's minus 13. That's at point P. Let's see at point Q. At point Q, x is 2. At Q, x is 2. Get the gradients at that point. Okay, and that will be equal to 3 times 2 squared minus 12 times 2 minus 4 over 2 squared. That's 4. And that will give me 2 squared, that's 4, times 3, that's 12, minus 24, minus 1. And that gives me minus 13. And that confirms that the gradients, since the slope is the same, the slope at s equal to 1 is equal to what? The slope at s equal to 2. So this is what we have done that. So this confirms that the tangent to C at P and Q are parallel. The tangent to C at P and Q are what? Are parallel. Okay. Let's quickly find the last one, the C part. Find an equation for the normal. Find an equation for the normal. My friend, I give question. If you give a question, you have to be online. You have to wait. You can't just drop a question and disappear. You have to be online, okay? Because the question, there is a mistake there. So please, you type that question, then I will solve it. You type the question, I will solve it. Okay? So the C part, find an equation for the normal to C at P. Okay? So equations of normal is this. Equations of normal is this. So that's the formula for equations of normal. And that we got to what? At P we have these coordinates 1, comma minus 1. That's our point P. So that's what we have there. 1, comma minus 1. And now we got to what? Plus 1 here. The gradient is what? The gradient. We got what do we have for the gradient? Let's check that. The gradient at point P. The gradient at point P is minus 13. That's a minus 1 by what? Minus 13 brackets x minus 1. Okay, so minus cancel. So we have y equal to we can that will be multiplied 2 by 13. That will be 13y plus 13 equal to minus 1 times x. That's minus x minus 1 times minus 1. That's a plus 1. Okay, and bring all the equation to one side. Bring all the equation to one side, and that will be equal to what? 13y plus x. Okay, and then 13y plus x. This 13 minus 1, so that's a plus 12 equal to 0. So that's that on that question, equations of normal. So that's that on that question. If you're just coming in, you are highly welcome. Okay, begin to share, like the video, subscribe to the channel. They are yet to do that. Okay, for the returning viewer, thank you for always coming on board. Begin to share the links across your different platform. Okay, make your comments, send your questions. We attend to that. I'll check my friend now. If he has corrected the questions, then we'll solve it. Okay, so that's that on this question. I'll quickly recap now on equations of tangents, equations of normal. I'll do recap. Then after that, we'll check the comment section. If there's any question, if there's none, then we'll take a break and come back again for mechanics M1. Mechanics M1. Okay, we'll go to kinematics. Okay, so thank you for staying by. Let's check the questions and then we'll do recap. Okay. I've said that if we check the board, I said the y dx is m. I said that the y dx is m. I mentioned that the y dx is m. I'm going to do recap shortly. I'm going to do recap. Okay, I said that the y dx is m. Okay. Okay, vector is noted. Vector is noted. We look at that. Hopefully by next week we're going to vector, and if possible this week we start vector also. If possible this week. All your questions, all your comments is highly noted. All your comments is highly noted. Okay. All your comments is highly noted. Okay. All your comments is highly noted. Okay. So let's look at let's do recap briefly. Let's recap on these but this is the end of this solution to this question. So let's quickly do recap. Okay. Yeah, we are looking at equations of tangents and normal. Okay, equations of tangents is of this form. Is of this form. Okay, where your m is the y dx, which is the gradient or the slope, is the gradient or slope. Okay, for geometry you can also get your m if you have 2 points. Maybe you have 2,3 and 5,6. you can get your m for geometry. But this one we are using calculus. We are using calculus to get the gradient. We are not using 2 points. We are not using geometry. Okay, we are using calculus to get our m. Okay, so m is the y dx. That's the differential coefficient. Your x1, y1, these are the coordinate points. These are the coordinate points. Okay, these are the coordinate points which will be given to you. Some question will give you 1 point, maybe x is equal to 2, then you get the y. Okay, you get the y by making substitution to the given function. Okay, so that's that on the equations of tangents. You can as well use this equation. You can as well use this equation to get the equations of tangent. This is the slope intersect form. You can use this form. Okay, and let me quickly buttress this. Imagine you have 2,5. You have your m as 5, for example. Okay, you have your points. Let's call the point P. Point P, you have 2,5. You have your dy dx, your gradients. You have your gradients as 5. Let's make it 6. You have your gradient as 6, and you want to use this equation, okay, to get the equations of tangents. It's very simple. Very simple. What do you do? What you do is very simple. Your y will be this one. That's your y. That's 5. Your m, which is what? 6. Okay, times x. Your times 2. Your x is 2. Your x is 2 plus c. Then you make your c the subject. You make your c the subject, which will be your c will be minus 7. Your c will be minus 7 if you make it a subject. Then you now go back to this equation and plug in your c. Go back to this equation and plug in your c, which will be equal to what? Y equal to what? Your gradient is 6, and your gradient is what? Minus 7. Okay, so you can use this equation or this equation to get the equations of tangents. The ball is in your court to determine which equation you want to use. Okay, you can use this one, you can use this one. Okay, on the final note, I'm going to equations of normal. Okay, equations of normal. Let's go there and make explanation, and after that we'll take a short break and we'll come back for mechanics. Okay, let's quickly do that. Let's do that. Equations of normal. Equations of normal. Okay. To get equations of normal, step 1, you need to get the gradient of normal. You need to get the gradient of normal. That's the first step. Get the gradient of normal. That's step one. Get the gradient of normal, which has this equation, minus 1 over m, either m1 as you want to call it, or just call it m. Okay, that is the equations of normal. Okay, after that, then you can now write the general equation of what? Of normal. So the equations of normal, equations of normal, equations of normal will be equal to what? Will be y minus y1 equal to what? The gradient of the normal times what? X minus what? X1. And that's that. It's as simple as A, B, C. But it's not just as simple as A, B, C. This call for frequent practice. Frequent practice. The more questions you solve, the faster you think. The more questions you solve, the what? You become experts. More questions you solve, more understanding. Okay, more understanding, and then you save time in solving questions. It's not as simple as ABC. This call for what? Call for practice. Look for questions, solve exam questions, pass exam questions, solve your notes. Okay, ask question. Okay, by so doing, you find it easy. Okay, and that's that on that. Let's check the comment section. Then after that, we close it. Okay. Yeah, thank you for that understanding. Okay, thank you. Limits, okay, it's noted. It's noted. I didn't noted for limits. We look at that. We look at that. Okay. We look at that. Thank you for subscribing. If you're yet to subscribe, please do so right now. Do so right now. Do so right now. I think we should take one more questions. Let's see if we can have one more questions. Let's see if we can take one more questions. Let's see if we can take more questions. I want to change one of you. Where do you give me? Just 3 minutes. Which one I should remove?
I don't know. Okay. Like what's it?
I think at this point we need to take a short break. Then we'll come back for mechanics M1. Okay, let's go for break for like 30 minutes. Then we'll come back again for another episode. Okay, I want to say thank you for coming on board. Thank you for subscribing. Thank you for the like. And thank you for the sharing. And if you're yet to do that, you can do that now. Thank you once again. See you again. Bye-bye.